working a problem today that's quite similar to the 20th CMO, the Canadian Math Olympiad. I'm just using different constants, but you end up with a non-integer value of alpha, it turns out. And alpha is a real number. We don't have to specify that. It will work out. You might think alpha would be another integer. It's not in this particular case. It was in this problem with different constants. Now, the simple approach, and I watched Michael Penn do this, and he did it in an unnecessarily difficult fashion, I thought. So the simplest idea here is just to presume we have a common root, okay, which is a given. Okay, we use that and just substitute it into both equations and subtract them. If you subtract equal equations from each other, you obtain an equivalent single equation, okay? So we do exactly that. I've already done most of the work here. The subtractions, 18 minus 81 is the negative 63 right here, and of course 76 minus 67 is the 9 you see right here. Factors very nicely here. And we get two constants, and it's clear by inspection that C is equal to either the positive square root of 7 or the negative version. So that part of the problem went quite well. The constants were designed to lead to something like this, you know. So now all that remains is to take both of these values of C and substitute it into either equation. I'm going to go ahead and pick the bottom equation right here. So this would lead to the square root of 7 squared is equal to 7. So this would lead to 67 times 7. 67 times 7, we'll use the dot there to connote multiplication. And then you have then alpha times root 7. Remember, C is root 7 plus or minus root 7. You get plus 81 equals 0. Now let's see what happens here, folks. When you add up, this would be 7 times 67 is 420 plus 49, right? 7 times 60 is 420. So this would be 469 right here. Okay. That multiplies out to, I think I've got that right, 7 times 60 is 420 plus 49 is 469. Now if you add that to this number, what do you end up with? You end up with 550, right? You end up with 550. If you take it to the other side and divide by root 7, you end up with alpha. Okay. This would imply alpha equals 2 minus, remember you're taking 450 to the other side and then dividing by root 7, so you would have minus, 550, I'm sorry, 550, my bad. That's 550, right, folks? Make sure you check me on the arithmetic. I'm pretty sure this is right. Minus 550 divided by root 7. Okay. And of course, you can do the standard rationalized trick. Call this minus 550 kind of bubbles to the top. You multiply by root 7 over root 7 is what's going on. I'm leaving that step out. But so you'd have minus 550 root 7 over 7. Okay. Now note that's when we used alpha equals to root 7. Now if you used if you use C equals root 7. Now if you use C equals to minus root 7, let me just write this here. I won't go through all the steps again. But C is equal to minus root 7. You can see pretty easily that just leads to alpha equals to positive, all right? The same answer we got a while ago. So they're additive inverses. So we have 550 root 7 over 7. So those are our two alphas. They're irrational numbers, but that's it. That's how it's done. And again, I think the one in the Canadian Math Olympiad worked out to some integer value. It was designed to work out to an integer value. But the work's about the same. Slightly more work. It's tedious dealing with irrational numbers, I guess. But anyway, those are the two solutions for alpha. And again, I just plugged into this bottom one since 67 is a smaller number. But those are the two values of alpha that ensure that we have a common root. All right. And notice we never even found the common root. Well, we know what the common roots are, but we don't know what the other roots are. There's two other distinct roots, but that's not what the question called for. But you could find those also. Okay, thank you for viewing.